Hi, welcome to Martian Technologies and a demo session on Big Data Hadoop. So the agenda for this particular demo session is to understand these points that you can see on the slide, as in what is big data. Then we will discuss a kind of point which is making us or industry or a company to shift from something called as data to big data, right? As the big data name suggests, it is something related to data itself, but there are a few things that are added to data, and big data do exist, kind of thing. After this discussion, we will discuss something in terms of real world use cases, so that you will be able to understand the exact problem. And in the technical aspect of the big data, we will try to see, okay, by use of the technology, how I can provide a solution to the problems which comes under big data category. So this is about the overall agenda of the today's discussion, and let's get started with what is big data. So what do you mean by big data? Big data, as its name itself suggests, it is something related to data, right? So basically there are a few parameters that are making this shift from a concept called as data to big data. We'll try to understand those concepts, right? So first fold for this particular shift is the cost. Now when I say cost, it is about a cost which is related to storing the data, right? So if you think of a scenario which was existed before 15 to 20 years, how bank used to store the data, or how a particular grocery shopper used to store the data. So most of the transaction were stored on register or papers, or we can say the medium was paper and pencil, right? Then you have floppy disks, then you have CDs, then you have DVDs, pen drives, and this evolution will go on and on and on. So what is the unique factor that is changing throughout these phases is the cost to store the data, right? If you think of a CD drive, so to store 700 MB of data, you need to have at least 100 rupees or 150 rupees or so, right? Then you have then you have DVDs, which is like more cost efficient, I would say. Then you have pen drives, and now you have external hard disk, and so just try to compare two example. Let's take two example. One is CD and another one is pen drive, let's say. So to store 700 MB of data, it was like 100 rupees, let's say. And now if you go into the market and ask for a 16 GB of pen drive or so, you will definitely get it within 200 or 300 rupees, or rather if it is a sale, then you will get it in 100 rupees as well. So basically the cost to store the data is getting minimized day by day, and that is why the appetite of companies, organization to store the data is getting increased. So this is like inversely proportional, right? So cost is one of the paradigm to increase or to have this shift from data to big data. Now what is the next thing? Next thing is necessity to store the data. Okay, that is fine. Cost, because cost is reduced, that's why people want to store more and more data. But this doesn't make sense, right? That only, okay, cost is less, so let's store more and more data. Unless and until your business or you are not getting anything like inside information or some information which is uh, you know uh, which is being used by your business, then there is no point in just storing the data, right? But yes, if it is a bank, if it is a retail customer, or if it is some e-commerce customer, e-commerce vendor, like we have Flipkart, we have Amazon, we have a number of e-commerce vendors in various categories nowadays. Unless and until they understand the behavior of their customer in a very accurate manner, they will not be able to recommend them various products in a very accurate way. To explain it more, that if you want to understand the behavior of your customer, when I say behavior, it comes under, okay, what are the likes of your customer, what are those things which your customer don't like, what are the things which your customer usually gets because of his or her own needs, is should be understandable by a company. If they understand it in very well manner, they will be able to recommend them their necessary products in more accurate way. And this particular perspective is beneficial to both the entities, I would say, a customer as well as a vendor, let it be a e-commerce vendor, let's say. So this is beneficial to these both entities. How customer is getting benefited? So he is getting benefited with these three four points. One, he is getting a product recommended and it fits its exact needs. So everybody will be happy if we are getting a product, a nice product, which is exactly fitting our needs, right? Then, due to the competition in between all these e-commerce vendors, they are trying to purchase that product with some discounts and lesser price. So this is again one more benefit that we as a customer will get, that we are going to get it in less cost. Now, how businesses are getting benefits out of this storing more and more amount of data? One is, like as we discussed, they do understand the exact behavior of their customer, so that they can recommend them a more accurate product which will fit their needs. This will build a brand for that particular e-commerce vendor, which is like the most important thing, that company branding or so. Right? And obviously they are getting more and more business. If suppose I am satisfied with services given by any of the e-commerce vendors, then definitely whenever next purchase I will do, I'm gonna to hit their website and check what is the cost of this particular product, is there any offer with that, and etc. So this is how these two entities will get benefited by storing more and more amount of data. And another side of the coin is, when I'm thinking in terms of a business cost, I'm not that whatever cost I'm going to need to store that particular data is something bearable to me, and that's why people want to, or businesses want to store more and more data. Here you can take a bank example as well. Maybe 10, 15, 20 years back, what kind of data a bank used to store? You just think of it. Just, what is the closing balance of this particular customer on this particular day? So maybe 4 or 5 transaction per day per customer. So this is what the frequency of a bank to store the data related to that particular customer. But if you think of today's paradigm or today's appetite of a bank to store the data related to their customer, is they just want to know that what their customers are doing every minute. Okay, at 10 o'clock you credited some amount to your bank account. At after 2 hours at 12 o'clock you went to this ATM at this uh, time, and you withdraw on, let's say, rupees 5,000 or so. So this is minute information. This kind of minute information they want to store about their customer, so as to understand, okay, what my customer is doing. He is going to any of the e-commerce vendor and he's trying to pay the the charge or whatever that product price is using this particular credit card, and every month he does this, or kind of whatever behavior they do have related to their customer, they want to know. And that's why they want to store more and more data, right? Because they are getting insight information out of this. And if somebody is getting insight information out of this, their customers will be happy, and the companies or organizations will get more and more business. The next point is importance of connecting data from various sources. So when I say various sources, there are few things that are coming into this particular shift is the evolution of social media channels, right? If you are, if you go and see in any of the part of this particular world, you will not, there are probably very less chances that you will have a customer or you will have a human being which is not having email account, Facebook account, Twitter account, and okay, whatever we have social media channels nowadays. So the impact of this particular thing onto humans lives is social media channels knows almost each and everything about their users. That okay, this user from date 15th of January to 20th of January was in Bangalore for some meeting at some of conference room in Whitefield or so, right? So basically, let's take example of 2 to 3 channels itself. One is, let's say, Twitter, and another one is let's say any of the email services. So both these accounts are related to the same customer, and whatever behavior of this customer can be very well understood if we connect his email account with his Twitter account, so that the company will get more and more information about that particular customer. And obviously, when they will get more and more information about that particular user entity, they'll be able to understand that particular user entity in more correct way. And again, it comes to the business part. So it is important, as mentioned in the slide, it is important to connect data from various sources. When I say various sources, let it be a Facebook data of that particular customer, Twitter data of that particular customer, or any other data of that particular customer. Let's take example to understand this particular connecting data from various sources. Assume that I am traveling from Pune to Bangalore, right, with some airlines X. Let's take example X is a airlines through which I am traveling from Pune to Bangalore, and somehow while traveling I am not happy with whatever services that X airlines has provided to me. So what is that thing that I will do first? I will go to my Twitter account and I will tweet there that I was traveling from Pune to Bangalore, but I am unhappy with the services given by X airlines. This is the first thing I will do, and this is what the impact of social media channels on our lives, that people to machine interaction is becoming more than people to people interaction, right? Now there gonna to be a competitor to brand X called as brand Y. If that brand Y gets information about my tweet against, I would say, against brand X, then here is an opportunity to get more and more business to brand Y. Brand Y will send me a message saying that book a ticket next time whenever you will travel, book a ticket with us and get 20% of the data. Now, me as a customer is already unhappy with the services given by brand X. So there are very less chances or almost no chances that I will go and book a ticket whenever next time I'm flying. And anyways, brand Y has sent me a message saying that I'm gonna to get 20% of the discount on the ticket if I book a ticket with brand Y. So 100% I will go to brand Y and I will get a ticket. So this is now why this particular ticket is being booked by me to brand Y, because I tweeted that I am unhappy with brand X. This tweet is being tracked by brand Y, and then they recommended me, or then they predicted that okay, let's give this guy a 20% or whatever that number is, a discounted price ticket, and this is how they are getting more and more businesses. So this is why, to get more and more business, now in this particular scenario we have two entities, me as a customer and brand Y as a businessman, or a company, right? So what benefits we both are getting here? Because of we have this data connected with each other, I am getting a ticket with 20% of the discount, that is clear cut benefit to me, and brand Y has got more business. So this is why it is very important to connect data from various resources so as to make our lives better, and obviously companies will get more and more businesses out of it. So this particular use case was one of the examples. You can apply this particular use case to any of the business domain. Let it be a education domain, let it be a healthcare, let it be a bank or financial domain. So you have various data sources through which your customers are already posting some of the information. If you want to understand, this is very simple straightforward thing. If you want to understand your businesses in more accurate way, go there, go to those channel, get those data, connect those, try to process those and get insight information out of those data sets. And that is why it is important to connect data from various sources. So these are the 3-4 factors that are making this shift from data to big data. As we already discussed, let's review those points. One is cost. So let's connect these 3 points itself, right? If I am a company, then what is my target is to get more and more business. How am I going to get more and more business? Is by getting more and more customers. So what is that particular parameter? If I provide, then customers will get will be happy to get service from me, is to give them nice service and discounted price, or I will not say every time you will get a discount, but more precise file that will suit their pockets. And obviously this can be done unless and until you have some information about those particular customer. So we explained importance of connecting, we explained necessity to store the data, and obviously when you need to store the data, you need some storage medium. And when you need to purchase some storage medium, the cost is a factor which is important when each and every company will consider, okay, what is the cost of storing this particular data. That's why these 3 points are pretty much important to make this shift from data to big data. Now, whenever we are trying to define some technology or some concept or domain, it will make us easy if we have some proper definition of these particular things. So here in this particular topic we'll try to define big data with some properties. Now it is, since now you know that how vast this concept is, it is very hard to define the exact definition of this particular big data, but we'll try to put this concept in four major properties, and this is kind of a approximate definition of big data. That, and you can think like this, that if a data set is satisfying these properties, then okay, let's call this particular thing as big data. So what are those four properties? First is volume, next is variety, then velocity, and then veracity. We'll discuss one by one. Now, what do you mean by volume? So volume is something which is directly related to the size of the data. And as we discussed, due to the evolution of the internet and social media channels, the volume of the data is enormous, and that is getting generated in enormous way. You just don't have a control over it, because you cannot control the tweets done by your Twitter user, you cannot control the Facebook post done by your Facebook users. There are weather sensors, there are parking sensors. Each and every device is generating some or the other kind of data, and that's why this volume is one of the main properties of big data. But when we consider this particular volume, there is no finite amount. For example, if the amount of data, if the volume of data increases 500 GB, then let's call it as big data. No, this particular parameter or this particular number depends on organization to organization. Let's take an example. Suppose I am a startup, right? I have just started my operation. So for me, maybe 100 GB of data, or for me to handle 100 GB of data every day is a challenge. So for me as a startup organization, 100 GB is my big data. The volume equal to 100 GB is my big data. But if we are talking about some big giants, technological giants like Google, Facebook, Twitter, LinkedIn, blah blah blah, then for them, like, they are generating, let's say, 20 terabytes or 20 petabytes of data per day. So for them, if I compare this particular with my earlier example of startup, then for them handling 100 GB of data per day is not a challenge. So for them, this particular number is maybe 20 petabytes per day. So that particular number has to be decided by organization, that okay, what is that data size or what is that volume which I cannot handle, and that is going to be a big data for that particular organization or a company. The next property is variety. If we think of a data which was in the place 10 or 15, 20 years back, it was mostly 99% of the times it was text data, which you can categorize into a table, RDBMS table, or some Excel, or some tabular format, I would say. But if you think of a data which you are getting nowadays, which is coming from various weather sensors or sensors, parking sensors, then you have Facebook data or social media data, I would say, the channels like YouTube, Facebook, Twitter, where you have text data plus audio plus video plus images. So just compare these things with the property called as variety. So nowadays you have data in various variety. You have text, you have audios, you have videos, and you have images as well. And you have to consider those while processing the data. You cannot say, okay, let's ignore audio, video, and images, and just let's consider only text data from Facebook or from Twitter. No, that is not the practical thing. You have to consider all the types all the varieties of data when you say that I want to process some set of data. So this is about variety. Velocity. Velocity is the data that is getting generated per second or per some time unit. That can be second, millisecond, nanosecond, whatever you apply. And you just think of this with the social media channels again, as an example, or a e-commerce related thing. How many are the users of one single company called as, let's say, Facebook or Twitter, that are posting something on their own accounts, right? So if we go and try to calculate the velocity of this particular data, it is something that is intangible, right? But it is huge. And ultimately, veracity is like trustworthiness of the data. Okay, that is fine. We have various channels, or I would say platforms, using which we can create the data, and we have customers who are using that particular platform. But whatever they are posting onto their accounts, or using their tweets, till what extent we should believe into that particular data? Is it trustworthy to take a decision, right? So this particular point comes under this veracity thing. So just to define big data, if the data set that you are dealing with is fitting into these four properties, then you can treat that particular data set as a big data, right? So these are the four important properties of big data. Now let's delve into the technical aspect of this particular problem. Up till now, whatever we have seen in this particular slide or the previous is like industry shift from data to big data. All this discussion was majorly into the business side of the problem. That okay, what is this big data, or what is that shift that is making us to go from data to big data? What are the problems? What are the solutions? If they do exist in the market, then how customer and companies are getting benefited? All these were the business level discussions, I would say, which is only one side of the coin. The another side of the coin is okay, these are the problems that do exist, and we need to use some technology or some handler which will solve that particular problem, or the problem which is being caused by evolution of big data. And when we say evolution of one of the a big domain as big data, then there are various opportunities as well, that we can provide some better solutions to your customer, and there are various things that can be listed. But you must have a strong technical use of some of the technologies to solve that particular problem. So here in this section we will take a look into the technical aspect and how Hadoop is a best fit to solve big data related problem. So if you want to learn any technology or anything, any new domain or so, there are two important parts that is like the heart of the complete system. One is data storage architecture, that okay, there is data, there is big data, how your technology is going to store that. And the another one is data processing algorithms. What are the algorithms that you are going to apply onto the stored data? Because if you want to process the data to get some insight information, you have to store it somewhere. Now the data which we are talking about, big data, where you can't just imagine of what kind of volume it is, what kind of variety it is, what is going to be the velocity. So you must have a stronger storage mechanism which can handle all these properties. Your system, your storage system should not fail if you have huge amount of data that is going to get entered into your system. Your system should not fail if you are going to store textual data, audio data, image data, and video data into your system. It should not have any constraint that, okay, my system can only store text data. No. If you are dealing with big data, according to the properties of data, you are gonna to get huge amount of data with variety of data types, and you are going to get the data frequently in enormous amount. So you have to consider these particular properties while architecting your storage media, right? Now the another side, again another side of the coin, is data processing algorithms. So there is no point in just storing the data. Okay, you have designed your storage architecture or medium in such a way that it can handle any amount of data, it can handle any kind of data with maximum velocity. That's fine. You do have a smart mechanism to store the data. But is there any use of storing the data just for storing purpose? Okay, that's fine. I do have data and let me store it. That's it. I don't want to do any processing on that data. If you don't do any processing on that particular data, then is it of any use? Unless and until you are getting some insight information from that particular stored data which is useful to your business, there is no point in just storing the data. So the data processing algorithms, right, are also equally important as that of storage architectures. You must have equally smarter algorithms which will go process that particular huge amount of data and come with some insight information. So for this particular big data problem which we are discussing from past few minutes, has two, I would say two pillars. One is storage, another one is processing. And how Hadoop is the best fit to process this particular big data is Hadoop takes care, or Hadoop technology or Hadoop ecosystem takes care of these both pillars. I would say that to store the data, Hadoop has a ecosystem called as HDFS, and to process the data, Hadoop is been architected using a open source data processing paradigm called as MapReduce. Right? So you can say HDFS and MapReduce are the heart of this particular Hadoop ecosystem. Right? So just to explain more on HDFS part, HDFS stands for Hadoop Distributed File System. It is a distributed file system where you can connect various workstations together, and you can distribute your data onto all these particular workstation, and you can process those particular workstations or the data that is being stored on those particular workstation parallelly, so as to get the results faster. Now this is about the business level discussions, as well as technical, what are the technical aspects that you must know before learning any technologies. Now at Martian Technologies, we do have a very in-depth course about big data using Hadoop. I would say there are many more technologies in the market which will process big data, but the best fit that we feel to process or to provide solutions related to big data is Hadoop, because this is like a one-stop solution. You have all the storage taken care by your Hadoop ecosystem, as well as we saw, there are two pillars. One is storage, another one is processing, as well as there are very strong algorithms in your Hadoop ecosystem which will process your data equally in a smart way. So here at Martian we'll try to dig deeper and deeper into Hadoop architecture part as an HDFS as well as MapReduce, and there are few ecosystems. So whatever 7 ecosystems you see here, I just have listed it, you know, the ecosystem which are very much important, but there are few other ecosystems as well that we will discuss in the long run of the course. So we'll go through detailed Hadoop architecture in the actual course, and after that we'll be having hands-on session purely dedicated to HDFS, MapReduce, then Spark with Scala. Spark is again a data processing ecosystem, and Scala is the paradigm using which you can write Spark program to process the data. Again, there is one more important ecosystem in the stack is Hive. Basically, Hive is a Hive query language. So you can basically write queries analogous to your SQL queries to process the data which you have stored in HDFS. Again, the next ecosystem is Pig Latin script. It is just like a scripting language which is been again preferred by scripters. We'll discuss about this particular Pig Latin script, and we'll try to solve some of the real world use cases using the ecosystem. Then we have a topic on NoSQL database. So when we say NoSQL, it is not like don't use SQL, because it sounds like that, no SQL, but it is like not only SQL. So NoSQL technologies are value additions to your existing SQL technologies. So NoSQL doesn't stands for don't use SQL, but it says that not only SQL but take something more than that as well. So we have two ecosystem under NoSQL sections. One is HBase and another one is MongoDB. Nowadays HBase and MongoDB are being used extensively in the industry. That's why we have this topic. Along with that, we'll be having various other ecosystems as well, but these are the ecosystem which plays a very important role when you want to learn Hadoop ecosystem, when you are thinking in terms of developing solutions, when you are thinking in terms of architecting solutions using Hadoop, and the related information. Along with that, whenever we are learning this particular course, I will be providing with you with more and more real world use cases that I usually experience in my work and all those things. So this is about the demo class, and for more information you can contact to Martian Technologies LLP. You can go to our website http://martiantech.com. You can visit our office, you can reach us to this particular contact number, as well as you can email us at info@martian.com. Thank you. Thanks for attending this demo session. See you.